Hi, this is Bruce Cripps from Phase 2 Horizon. Don Shield, glad to have you on.
Hello, everyone, and thank you for joining us today. I would like to introduce Jeff Morin, Director of Systems Architecture, and Tony Casterline, Field Applications Engineer, who will be speaking on Lumissil's third-generation capacitive sensing. Jeff will review the Gen3 capacitive sensing technology, and later Tony will show us how to use the Lumissil development tools and doing a system for your application. And at the end for Q&A, Anay Kajasha, Director of MCU MPU Product Marketing, will join us with Jeff and Tony to answer any questions you may have. I will be muting everyone during this time and unmute during Q&A. Throughout the presentation, you may type your questions out in the chat window down below, and we'll get to them at the end of our presentation.
Okay, thank you for getting us started, Vivian. And thanks to the audience for joining us for this webinar on Lumissil's Gen 3 Capacitive Sensing. I'm Jeff Morin, Director of System Architecture based near Detroit, Michigan for Lumissil. First, let's have a short introduction of Lumissil Microsystems. We are a fabless semiconductor company based out of Milpitas, California, with about 300 people globally. We design, develop, and market innovative analog and mixed signal devices. We have 6 foundry partners and 6 back-end partners. We are spread around the globe with offices in all major regions. We take a lot of pride in being a resilient supplier, meaning we put much effort into building a resilient supply chain and a strategy ready for any kind of disruption. At Lumissil, we have 5 pillars of growth, or these are the 5 categories of the products. We first have LED drivers, which include automotive lighting and special effects RGB drivers for both automotive and consumer grade. We have MCU-based touch keys sensors. We have audio and power management, wired network, and embedded controllers. And this includes ARM, RISC MCUs, and AI-enabled MPU processors. There are 4 key markets that we service. One is automotive, and that's with LED drivers and MCUs, touch keys. We service consumer, which is, again, a lot of LED drivers. Networking, which is interconnection around the home and automotive. And also we serve industrial/medical with smart appliance control and interfaces for enhanced user experiences. So let's first get into an overview of what capacitive sensing is. Lumissil's third generation of capacitive sensing technology can be found in our MCU and touch key controllers. The technology can be used for making touch keys or proximity sensing. It marks a new milestone for detection, reliability, and low power consumption as well. The first benefit of touch keys is durability, since there is no moving parts to wear out. It also enables the creation of a modern, sleek look, since it opens new design possibilities. And third, its cleanliness, since there are no crevices for dirt to collect and can easily be wiped clean. The benefits of proximity detection include energy efficiency. For example, in a wall or appliance-mounted display, there is no reason to leave it on unless someone is in front of it. Capacitive sensing can be used to detect when a body gets within a using distance of the display, thereby saving energy. It can also provide enhanced safety on equipment. For example, a large industrial machine won't operate as long as a user's hands or fingers are near a cutting tool. Or the opposite is true, that a large tool will not activate unless an operator is present. Proximity activation is also sanitary, since a contactless gesture could activate a system such as a paper towel dispenser or a faucet. Applications for capacitive sensing are found in appliances, automotive, industrial, ATMs, medical devices, and smart home devices as well. Next, let's review the capacitive sensing basics. Its basic operating principle is that it detects a key touch or proximity event by measuring changes in the capacitance of a sensor, aka an electrode, when a conductive object like a finger or a hand approaches or touches it. Figure 1 is a side view of a simple touch key electrode on a PCB. The cover, PCB, and circuit for the baseline capacitance represented as C1. When a hand or finger touches or comes near the electrode, the total system capacitance will increase and is detected by the capacitance measurement. Although the operating principle is not complex, the circuit for measuring the change in capacitance is where the magic happens. There are several design tricks that Lumissil has developed over the years that prevent false activation from EMC, water droplets, or other changes in the environment. Also, design tricks to ensure repeatable and reliable activations over time as well too, such as calibration or automatic calibration. Not all capacitive sensing blocks are the same, and you'll find Lumisils to be a leader in this field. Lumissil's third generation of technology supports two types of sensing configurations. There's self-capacitance with an optional active shield, or mutual capacitance, which I'll explain in a minute. Both configurations can be supported on the same MCU, but with separate pins. Self-capacitance has a higher sensitivity and is best for touch keys. The circuit below shows a side and top view of a typical touch key button with an active shield. More about the active shield though in the next slide. Mutual capacitance is used for longer range sensing and is best for proximity sensing. It uses two electrodes where one is a transmitter and the other is a receiver. This configuration helps to improve the sensing distance. And here in this block diagram here, you can see this one is the transmitter and this one being the receiver. Now let's review the key features of Lumissil's third generation of capacitive sensing, also known as Gen 3. The system is higher in resolution compared to many of our competitors and older designs. This means it is more sensitive to smaller changes in capacitance. It can detect steps as small as 3 picofarad and respond in as little as 125 microseconds. It is lower power. In fact, we can boast the industry's smallest key monitoring mode as low as 5 microamps when the MCU wake-up is enabled. It also features an optional active shield, which will eliminate false activations caused by water droplets or EMI. And lastly, this third generation features self-calibration over time, which will compensate for changes in baseline capacitance caused by the environment or material changes. Let's talk more about the active shield for the touch key now. Here's a top-down diagram again, but with water droplets on it represented in blue. Without the active shield, the capacitance of the system would have changed and could have caused a false activation. In fact, you can see this on many vehicles and appliances out there in the real world today with older technology. But the active shield that we've developed acts to cancel out the water droplets. In simple terms, the baseline capacitance of the active shield and the touch key change at the same time, so these changes can be ignored. When a finger touches the touch key, though, no change is detected in the active shield, and therefore it must be a valid touch. This video demonstrates how effective an active shield can be for an application like an automotive capacitive touch door handle. Many older cars with capacitive touch door handles will lock or unlock the door when water is splashed on the handle. In fact, I have one of them. Whenever I wash my car by hand outside, the lock is constantly lock and unlock, especially when I run the soap brush over it. These generally will operate again once they're dry. But as you can see, the system works regardless of water in this video. So let me play this again. Just watch very carefully there. And you can see he'll do a finger swipe on there to unlock the door. It opens the door. And then another swipe will close it. So even wet, still detects the gesture. Another good application for Lumissil's third generation of capacitive sensing is touch key behind metal. For example, an appliance can put their touch keys behind the stainless steel like shown on the Lumissil development kit in this picture. The diagram shows a side view and how these touch keys work. The stainless steel slightly bends under the pressure of the finger. The touch key is sensitive enough to even detect a small deflection by a gloved hand. Watch the bars in the video as the user presses the buttons here. I'll play the video. So watch he'll press on it with his fingers and then watch the corresponding bar there in the graphical user interface. And this is a good example of the user interface that you get with our development kit. Let's start to look at some specific applications for Lumissil's Gen 3 capacitive sensing technology. The first one we will look at is in the category of contactless sanitary devices. That is products like automatic hand dryers, paper towel dispensers, faucets, soap dispensers, and garbage can lids. Many of these types of devices can benefit from using capacitive proximity sensing. Today, these are mainly using passive IR, which is looking for the heat of your hand to enter the scene to activate the system. But these types of sensors have issues, and we're all familiar with that public bathroom where it's very hard to get the faucet or the soap dispenser to activate. That's because these sensors are easily disrupted by dirt or film on the optical window. Also, they are tuned to not activate easily to prevent false activations when someone walks into a room or a sudden change in room temperature is caused by the heating vents. However, the good thing about PIR is that they are cheap and low power. But our Gen 3 capacitive sensing with passive or active proximity detection can now compete on power consumption and the price, and the user experience is greatly improved. And for capacitive sensing, optical windows will no longer be needed to simplify the housing. In the block diagram, we see that the IS31CS8977, which is one of our low-cost 8-bit MCUs with Gen 3 capacitive sensing circuit inside. Here, the system is set up for active proximity, but this could also be configured for passive proximity or even a touch key if desired. Active proximity will give a bigger sensing distance up to about realistically 8 inches. The passive, using much less power, will be more about 2 inches of detection distance. But for applications, 2 inches is enough for many of these devices. The MCU can be in sleep mode, awake just enough to monitor the keys, then enter a full run mode when the activation is detected. Once it's woken up, it can then talk to the IS31PS7217 motor driver, shown in gray, to drive a brushed DC motor or solenoid, which then turns and controls the soap or the towel dispensing or air motor in the dryer. The CS8977 can also monitor the battery and periodically flash a low-level LED to indicate the low battery status if desired. Another market where Lumissil is expanding fast is the appliance HMI market. This can be both large and small appliances from refrigerators to blenders. Touch keys have become ubiquitous now since they are so easy to clean and reliable. However, many appliances with touch keys still struggle with water droplets on them to render them inoperable. My brand new dishwasher, it's literally just months old, when the water droplets get onto the touch keys at the very top of the door, so every time you open it, a little bit of steam can come out or water comes out, and the water droplets cause those buttons to be inoperable. So I have to dry them with a towel and then actually wait about a minute before they work again. But with our Gen 3 touch key and the active shield, this will no longer be a problem. In this block diagram, we see several Lumissil components. Starting with the MPU in blue, this is our X2000 or X1600. These MPUs are powerful multimedia dual-core MPUs with built-in memory and cybersecurity. They support camera, audio, touchscreen, and external storage writing. In purple, there are 2 LED drivers. On the left, it's the FL3240, which is used to drive indicator lights for each touch key. It's a 30-channel, 60 milliamp LED driver that allows for fine-tuning of RGB LEDs. And up to 38 milliamps per channel with 8-bit PWM control. It features EMI and noise reduction features on it as well. On the right side is the FL3749 to drive the backlight of the touchscreen. It is a 24-channel matrix LED driver with 16-bit PWM for smooth control. It features dot correction and current scaling. On the top, in the gray box, we have the IS31AP2123, which is a mono Class D amplifier up to 20 watts into a 4-ohm speaker for the appliance's alerts and chimes. And finally, in burgundy is the IS31CS8977, which is an 8-bit MCU capable up to 27 Gen 3 touch keys or active proximity sensing. As shown in the diagram, it supports the active shield to prevent any false activations and still operate in the presence of droplets. All of these products are available now, and we have the application engineers available to help guide you through the capacitive sensing design phase. Here we show an example of an automotive center stack, and it's not much different than the appliance HMI system we just reviewed. In the middle is the automotive version of the CS8977. This has enough touch key channels for the various vehicle functions like the radio volume, defrost on, AC, etc. In fact, we are finding that physical buttons are making a comeback in the automotive industry since the touchscreens take the driver's eyes off the road too long. Capacitive sensing touch keys are great for automotive as long as they are done right though. For example, the center stack of a Toyota Corolla uses a lot of touch keys, and it had very positive feedback. Also, note the two boxes in green here, the IS32IO1163. These are CAN system basis chips from Lumissil, and these take the communication burden off the host processor. Lumissil's third-gen capacitive sensing comes in touch key controllers, which are pre-programmed drivers ready for use in touch key and active proximity detection. So these come in pre-programmed, they're ready to use. You connect it to your host processor through I2C. And in monitoring mode, the host processor can go to sleep, and the CapTouch controller can then just monitor the touch keys, and if there's a touch event, then wake itself up further, and then also wake up the host processor as well. So you can see we have three different ones. We have the SC5117A, the SC5118A, and the SC5120A. Two of these will support an older generation of touch key, but for new applications, we certainly would recommend going to our third gen, which all three support. These all support the Shield driver, all have auto sleep, wake on with a touch event. Two of them can support the buzzer melody. And the biggest difference between these is the 5120A supports active proximity, and the 5117 and the 5118 will support passive proximity, but not the active proximity. So that's really the key difference between these. As you can go down the list here, you see they have all these other features, and they come in a 24-pin, 16-pin, and a 32-pin package, both automotive and industrial grade qualifications as well too. Lumissil's Gen 3 capacitive sensing technology is also available in 8-bit MCUs as shown in the table. This line of MCUs is very popular for embedded systems since they are very cost effective. They come with built-in memory, lots of analog features, peripherals, and IOs. We don't have enough time to go through all the details in this table, but they do come in two different temperature grades, industrial and automotive. Note that the CS8976 and the CS8978 come with built-in LIN transceiver and PHY. These are ideal for LIN nodes where one MCU can talk to the bus and host the node in one component and reduce a typical BOM. Another MCU of great interest is the one on the right side of the table highlighted in the red box. This is a new one and getting a lot of attention because it not only has the Gen 3 technology, but it also has 16 constant current up to 60 milliamp per channel LED driving capability. So this greatly simplifies an HMI design that has an indicator lamp with each touch key. So thank you very much, and this concludes the high-level overview of Lumissil's Gen 3 capacitive sensing technology. Next up, Tony will walk you through our hardware and software development kits.
Thank you, Jeff. Now let's have a deeper look at our capacitive touch technology. The SCE5117 is an ultra-low power 16-channel capacitive touch controller with a sleep current of under 10 microamps and an auto-detect for wake-up. An on-chip I2C interface serves as the communication port to the host processor. An interrupt can be configured and generated when a touch event occurs, and the SCE5117 can also support proximity sensing. Automatic baseline adjustments keep the keys calibrated in changing environments, and an actively driven shield output increases immunity to water droplets in wet environments such as outdoors, kitchens, bathrooms, etc. Perhaps a lesser-known application for capacitive touch is the ability to detect a slight deflection of stainless steel buttons. This allows for reliable touch keys in an environment that needs to withstand washing, harsh chemicals, or to be completely sealed from the environment. Now, let's have a look at the SE5117 evaluation kit. The evaluation board connects to your computer through the EasyISP programmer and debugger. The board features 3 touch keys, a detachable slider control, and a wheel slider control. It also has LED indicators for the 3 touch keys and a polyphonic beeper for generating tones. The evaluation kit is a great starting point for developing your own touch key designs. You can wire directly into real-world touch applications and experiment with your own touchpads or proximity sensors. Now, let's open the graphical user interface. Under the Settings tab, the Pin Assignment tab allows you to configure each I/O to be a touch key, shield, buzzer, or general purpose I/O. The default settings are loaded when you connect to the evaluation board, so you don't need to change any of the settings to get started. The Hardware tab lets you adjust the system clock and other core features of the sensor. Increasing the cycle count per key scan will increase the detection resolution, but also extend the scan time. The touch key clock can be adjusted as a multiple of the system clock. The initial setting delay can be used to allow a little time on power up for the CREF pin to settle out. Varying degrees of low frequency noise filter can be applied to the inputs. The next setting is the internal normal mode capacitance. We recommend this be set to twice the capacitance of the touchpad. The pseudo-random sequence enable can add some high-frequency noise rejection. The multi-frequency enable will scan the keys using 3 different frequencies to increase the noise immunity, but will also increase the scan time. The spread spectrum control allows you to distribute the EMI over a broader frequency range to help pass regulatory requirements. DC compensation can be added to the reference pin to help overcome a high capacitance touchpad. Now let's have a look under the General tab. Multi-key enable lets you select how many keys are allowed to be detected at the same time. If a key is detected for longer than the max duration time, the device will force recalibration. Several filtering algorithms are available, including jitter, median, average, and IIR. You can enable an external interrupt pin to wake up a host MCU. A couple of graphing options are provided, including a bar chart for visual feedback. A line chart for plotting the data over time, and a specialized slider interface that provides directional data and additional settings to configure how the slider will be interpreted. The Key tab allows you to configure and monitor each key individually, including the touch threshold, the noise threshold, hysteresis, baseline, debounce, and interrupt enable. Under the Sleep tab, you can set up the sleep parameters for the device, including how long to wait before going to sleep, which keys are monitored during sleep, and you can also configure the touch keys to have different operating parameters during sleep mode. The output settings allow you to assign GPIO to be outputs to touch keys. You can use this output to drive an LED or other external device. You can also assign a rule to the output to make it toggle, invert, be active high or active low. The I2C window lets you manually send and receive commands to the sensor and view a log of the commands. You can also save your list of commands to load and use at a later time. The SE5117 has a built-in tone generator for adding audible feedback to touch keys and creating different chimes or melodies. As you can see, Lumissil touch key controllers are highly customizable. All of the options featured in the evaluation software can be exported as a configuration file. This file can be programmed into the part, or the configuration can be sent over I2C from the host processor. Additionally, all of the touch key functionality is available for our 8-bit microcontrollers. You can download the touch key library from the Lumissil website and include it in your own source code. In this way, the touch controller can also serve as the host processor for many applications. Let's have a quick look at the development tools for our 8-bit MCU lineup. Lumissil has provided templates for Microsoft's Visual Studio Code and the Embedded IDE extension. This lets you easily configure the processor and use ready-made sample projects. We also have example code formatted for the Kyle compiler. We offer a complete selection of sample code for evaluating each peripheral, and we have design guides and application notes for many common applications. At Lumissil, all of our parts are designed to be automotive grade and AEC Q100 compliant.
Thanks, everybody. That concludes our presentation portion of the webinar. Now we're going to move into the Q&A session.
Any questions, please? This is Inayat. I'm Director of Marketing here. We are live. Jeff and Tony are also available to answer any questions. If not, you can always visit our website where we list all our sales locations, and we also have regional reps across US and Latin America. You can contact them as well. And one other point I want to highlight is where Lumissil distinguishes itself from several other MCU providers is we specialize in application-specific MCUs that target specific applications. We have several now, and we are also working on a roadmap of application-specific MCUs that are specifically targeted for both automotive and industrial applications.
Oh, there was one question in there if the video will be on YouTube. Vivian, I think the answer is yes, right?
Yes, this is being recorded, so it will be on YouTube shortly.
Okay, I think if there are no more questions, maybe you can we can conclude. Vivian?
Yeah.
I don't see any other questions coming up. Just one more point. We also have a follow-up session tomorrow, rather a similar session tomorrow at 6 a.m. California time, which is around 3 p.m. Germany. So in case if anybody wants to join or more clarification is needed, when you go through the material, please feel free to dial in.
Okay, well, thank you everyone for joining us, and hopefully you guys learned a thing or two about our capacitive sensing solutions and consider us for your next project. If you have any further questions, feel free to contact us. Our email is right here, marketing@lumissil.com. And also consider following us on our social medias for current updates. We're on LinkedIn and Twitter as well. Okay, thank you, everybody.
Thank you, Vivian.
Thanks, Jeff. Thanks, Tony.
Thanks, everybody.
Thanks, Naya.
Thank you.
Bye.
Bye-bye.
Thank you. Bye.
Bye.